also thank my colleague Dr. Kalai Selvi, who has helped me in this project as well as in getting some inputs for this write-up also. And at the outset, I asked Dr. Selvan about the type of audience. He said many non-veg nutritionists are also in this group. So thinking of those people also, I've just taken it slightly at a basic level. Not that I'm an expert in this area. So I thought it was necessary that we should talk some basics. So there are some veterinarians and others who are also probably working on similar lines for quite some time. So if it is kind of repetitive or if it is kind of basic, we can have discussions at the end of the lecture. So I'm going to talk about these things in particular, use in poultry, antibiotic use in poultry. What is the current status of residue in chicken meat? I may throw a few examples downright. And as a pharmacologist and a toxicologist, we are more interested in knowing what is the impact of residue. Does it really cause any harm to the consumer, to the animal, to the environment, etc., etc.? And the fourth point is what I am currently working on. We are indeed working on a project on monitoring of drug residues. In fact, in particular, our Chennai center, we have taken up chicken meat as our matrix, and we are working on, we have so far identified some 7 or 8 antibiotics for whom we have developed HPLC assay methods. So on that score, I am happy to discuss in this group. And of course, what could be done. Finally, we'll discuss about what could be done in the overall program as a society, as a country, what we can do to reduce this menace of residues. So to start with the food security, this famous Venn diagram we see, foodforruns.web. So we study about food security, under which is security, sovereignty, and safety. Security is food for everybody. Sovereignty is what I want to eat, I'll eat. And safety, that is what we are really talking about today, to have a healthy, nutritious diet, which will be free of contamination or degradation. So that point is very, very important, free of contamination. The whole topic is going to talk about what are the contaminants that we have, especially antibiotics. So antibiotics, for those who are veterinarians in this group and for those who are others also, the general public, today antibiotic is a public of debate in the common society. It is no more a domain of veterinarians and medical specialists. So antibiotics are one of the most widely used class of drugs. It is said that in veterinary practice, 60% of prescriptions are mainly antibacterial, chemotherapeutic agents. Still, they remain in the mainstay of treatment of infectious diseases, even for viral diseases. You know about people who are using azithromycin. Even for viral diseases, people still use antibiotics, thinking that it is going to take care of secondary bacterial infection. So what I am trying to say here is that whatever be the kind of infectious disease or surgical disease or traumatic injury, antibiotics are always there. And of course, antibiotics, they are the biggest servers of humanity. We all should note that 50 years back, infectious disease was the leading cause of death. Now, infectious diseases are no more a major threat in animal health, of course, in human health also. Even given a conditions like COVID, right now we have infectious disease are no more a big threat. Majorly, in the last 50 years or so, we have been able to overcome most of the infectious diseases thanks to the brilliant array of antibacterial that are available to us. In animal practice, why do we need antibiotics? It is common knowledge that dairy, poultry, and piggery have become a really, really big industry. They are assumed status of industry. In India, of course, piggery is not that popular, but world over, piggery is equally big. And of course, India is the leading product producer of dairy, and I think it occupies second place in the poultry product manufacture. Whenever things go big, there are always going to be intensification of systems. So when we talk about 50,000 animals, 50,000 birds, 1 lakh birds, you know that in a small space we have a huge number of animals. So when such a type of intensification happens, so overcrowding of animals is inevitable, and therefore increase in infectious disease is also very, very common. But we are nowhere in a typical backyard type of poultry. We have come much over and far beyond that. We are now in a industrial mode of poultry science or poultry production, and therefore infectious diseases are bound to happen. And if optimal biosecurity cannot be maintained, when I say optimal biosecurity, I am talking about the fact that we are not able to control the infection, then animal drugs, antibacterial drugs remain the mainstay. So the poultry farmer, please note that this particular lecture, I am going to talk only about poultry. So the poultry farmer has nowhere else to go except to resort to antibiotic therapy. How does a farmer or how does a veterinarian use antibiotics? So, of course, the first and foremost, we all know that whenever there is a disease, we are going to treat animals. This is very common in all pets, in all farm animals. Only the affected animals are getting treated. What is happening in poultry? We call it metaphylactic therapy. When we say we never distinguish treated and untreated, we never distinguish affected and unaffected animals, the entire flock is getting treated. This obviously has its own pitfalls. This is good in a way, because we are going to mix the drug in water and all the birds are getting, definitely those who have got even partial or low level of infection also getting benefited. But we are unnecessarily introducing large amount of antibacterials in the flock, and thereby we are coding for more and more resistance. Prophylactic therapy, it is also commonly practiced in poultry, especially. So as soon as the bird is purchased, people probably resort to using drugs like gentamicin, and as a part of feed or as a part of water, some of the antibiotics are routinely added. Even this is suggested by some companies, or sometimes veterinarians themselves, or more pathetically, farmer himself knows which drug to give at what time. I think the cross section of the class, they know that the average poultry farmer knows much more than even sometimes what a veterinarian knows, because such is their involvement and dedication to the cause they have taken. And as a result, of course, they're also going to use more and more drugs on their own accord. That's what I'm trying to say. Of course, using antibiotics as a growth promoter is discouraged world over in the last 2 decades. But we cannot rule it out completely. Still, it is happening in many parts of the world. And even though governments and agencies across the globe cry for reduction of usage of antibiotics, reduction in the usage of antibiotics just for the purpose of growth promotion. Here, the concept is that people believe that whenever antibiotics are mixed in the feed or water on a regular basis, there is a reduction in the harmful bacteria. This leads to normalcy of the intestine villi. The absorptive capacity of the intestine increases, and therefore the better absorption of and assimilation of nutrients takes place, and therefore the birds grow better and stronger and heavier. So this is the concept. Of course, this has its own negative side or flip side, and that's why world over people are not advising it. It is not a surprise to note that veterinary or livestock sector, including poultry, is one of the highest consumer of antibiotics, even when compared to human beings. You can see that 70% are by animals, whereas only 30% are by human beings. Please note that most of the antibiotics are meant for human beings. And of course, of the around 40 groups of antibiotics, 40 groups or 40 classes of antibiotics, 31 are even today important from the medical point of view. Medical point of view, I mean from the human point of view, from the treatment of human beings. In the pediatric ward, in the neonatal ward, even today, one of the maximum or one of the major causes of death happens to be antibiotic resistance, because most of them are already exposed to, or most of the bacteria like C. difficile, etc., are already exposed to antibiotics, which have made them resistant. So what is this? This is a kind of alarming factor that 3/4 of the antibiotics are even today medically important, but widely used even in livestock practice. This is just an assumption I have made. This at certain times is always, in a starting of lecture, it's good to alarm the people, not necessarily threaten, but alarm the people about the impending danger. So I just temporarily made from Maran 2008. Maran, this Netherlands revenue avoidance network, I think residue avoidance, I think they come out with this kind of report every year. 2021 is also out now, and in the Europe, Netherlands especially, there has been almost 30% reduction in antibiotics thanks to their network report every year. Say roughly you can see on an average a growing pig which grows for around 200 days, almost 35 days it gets some antibiotic. A broiler which is taken for 6 weeks, or by the end of 6 weeks we sell them, on an average at least slightly less than a week they are exposed to antibiotics. In a dairy cow, of course, dairy cow during most of the drugs are banned in milk, but during dry period, about the 2 months, at least 1 week they are exposed to antibiotics. In comparison, we can all think over, all of you can individually think over, when was the last time you had an antibiotic? Very, very rare. So that means that among food producing animals, the exposure to antibiotics is not uncommon. Of course, India is the leading player. It is in the projected increase. India leads the whole world by an expected 82% increase in antibiotics in the coming years. And of course, one more important story here is that the groups tetracyclines, penicillins, quinolones, and cephalosporins. These 4 important groups, the others are of course less important, amphenicols, macrolides. Of course, macrolides are also important. Recent azithromycin, doxythromycin, and clarithromycin, they belong to that group. But these 4 or 5 groups are very important because they are one of the currently used class of drugs, very highly used in the human being. So you can imagine how much more we are likely to increase. India, I'm talking about the Indian scenario, and there is an absolute need to rethink our strategy and to minimize this use, definitely. Being a pharmacologist, I cannot avoid describing these drugs. In a nutshell, I just like to go through about this. Especially, I like to talk the importance. Am I audible?
Yes, sir. Yes, sir.
Am I being followed?
Yes, sir.
So now and then I get a doubt, so that's why. You can always stop me, interrupt me if you want any query or this thing. So these are some of the important class of drugs which we of course talk in both BBS and MBSc pharmacology, and penicillins. Even today, penicillins, especially the beta-lactam agents, including amoxicillin. All of you might be knowing about amoxicillin, cloxacillin, one of the most important groups. Needless to say, penicillin G, the first antibiotic itself, is even today is useful, very much useful in veterinary practice. And cephalosporins, they are kind of ruling the roost in human medicine right now. We have a generation 4, generation 5 cephalosporin, cephalexin being the first generation. Even today, it is widely used in pediatrics. They are also very well used in veterinary practice also. Quinolones, again, another important group of drugs. Enrofloxacin, ciprofloxacin, all of us know. Very many drugs. Levofloxacin is another very popular drug, along with ofloxacin and pefloxacin, norfloxacin. They are of 3rd generation fluoroquinolones. They are very widely used, and they are very advantageous because of the broad spectrum and being bactericidal, and that is why all the more misuse. Tetracyclines, of course, right now most popular in veterinary practice, especially in poultry practice, but all of you know the importance of doxycycline in the human treatment as well. Sulfonamides, of course, one of the oldest class of drugs, most of us will remember, but thing is right now their use is kind of diminishing. In the last 2 decades, I can say they have been superseded by newer drugs, but that is again advantage. Some of the studies say that if some drug has been given up for quite some years, there is a chance of revival of its activity. So even again resistant species, sometimes sulfonamides, some newer studies are saying they are useful. But as of now, you can have it as sulfonamides are very least used. Macrolides, these tylosin, telmicocin are very specific for mycoplasma. Therefore, one of the commonest groups of drugs. I am sorry for spelling mistake. Tylosin should be Tylosin. So, but of course, equivalently, as an equivalent in the human being, you have azithromycin, roxithromycin. especially azithromycin is one of the most popular antibiotic right now in the human practice. Tiamulin is unique. It is used only for mycoplasma. We have done studies with all these three drugs, tylosin, tilmicocin, tiamulin. Right now, one more study is going on in tilmicocin, tiamulin about the residue pattern. Aminoglycosides, again, gentamicin is the most popular antibiotic. We have some newer drugs, kanamycin, amikacin, etc. also. Again, one of the important groups of antibiotics in the human beings. I always try to compare with human beings because all of you know that when there is a commonality of administration of these drugs between the human being and the veterinary practice, we must always be aware that there is a great possibility of resistance being carried from veterinary science or from the animals to the human beings. Nitrofurans, of course, thankfully they have been banned because they have been found to be carcinogenic. And lastly, chloramphenicol. Again, chloramphenicol is banned, but thiamphenicol and fluorphenicol are used in livestock, not in poultry. But chloramphenicol has been found to be, again, spelling mistake, I'm sorry, CHLOR. Chloramphenicol has been found to be causing aplastic anemia and therefore banned for any authentic use in the veterinary practice, especially food animals. Coming to the topic of the drug residues, so any pharmacology, just for the sake of a definition, any pharmacologically active substance and or its metabolite that are seen in the foodstuff from the animals to which these drugs have been administered. So we are administering antibiotics, mainly today's topic is on antibiotics. So we are administering antibiotics, and whenever we are able to retrieve or identify these drugs in the foodstuff, in the meat, in the milk and the egg, and also some of the other products, offals, etc. So they all constitute drug residue. Usually we discuss about ultra low levels. The international agencies talk about ppb or at the best ppm. PPT levels are not very rarely seen. Only for zero tolerance drugs like carcinogen, we talk about PPT, but that is more with the endocrine receptors and other compounds. PPB is or ppm for that matter, is the most common level that we are seeing. So factors are there, multiple factors that work from the antibiotic side. It depends on the lipophilicity or hydrophilicity. A lipophilic drug has high affinity to the body and therefore hardly ever leaves from the body. A good example is your ivermectin. Ivermectin takes a long time to leave from the body, and it can stay in the body for days together. Some of the tetracyclines, in fact, we have done one study, tilmicocin. We have found that it is there up to 22 days in the heart. And the pharmacokinetic behavior of drug, again, it goes along with the physicochemical property, hydrophilicity, lipophilicity, ionized nature, unionized nature. So all these modulate how much of drug is absorbed, where all in the body it gets distributed, and how slowly or how swiftly it is getting excreted, and all these going to make up the ultimate residue component. Of course, the biological process in the animals, the formation of milk, or the contents of milk and the egg, the formation of the muscle, the adipose tissue nature of the body, because lipophilic drugs tend to go and bind to adipose tissue. In some species, adipose tissue is part of the edible matter. So all these things play a role in determining how much of residue is present. Of course, for a schematic diagram, this is what happens. Normally in poultry especially, drugs are given orally, they are getting absorbed. We have done some studies on how much of the drug is absorbed and how slowly or how rapidly it is absorbed, but ultimately they all reach the blood. From the blood, they reach the tissue. The tissue component of the drug is what finally makes the product. So here we talk about egg or meat. So the blood component and the tissue component, these go to make the egg or meat, ultimately where we are interested in knowing how much of antibiotic is there. Of course, liver and kidney, they take the maximum, I can say, trauma or maximum assault of the drug, because these two organs the drug has to pass through these two organs for process and ultimately getting excreted. So it is the role of egg and meat and also the liver and kidney which are important. Tissue concentration is also important. We have done a study. In fact, we checked how much of tilmicozin and tiamulin were present in the lungs. We could record significant presence of tilmicozin in the lungs. That is important from a pharmacology point of view, from a therapy point of view. But from a residue point of view, the role in the egg and meat, the presence in the egg and meat, as well as the liver and kidney, they are very important. So regulatory agencies, regulatory authorities also, whenever they describe residues, they talk about the produce, mainly egg and meat, and also they talk about the levels in the liver and kidney, because these two organs bear the brunt of the antibiotic assault. This is another schematic diagram. That is what you normally they like normally routes of how the animals get these contaminants. Of course, this picture talks about all the contaminants, including heavy metals and pesticides, which are received from the environment. The topic of the antibiotics are mainly received by the animal by the administration of veterinary drugs, mainly antibiotics. Of course, anti-inflammatories and growth promoters are also there, and we also get heavy metals and mycotoxins and pesticides through livestock feed and water also, because they are one of the commonest sources of these drugs. And once the animal receive them by oral or some other route, they finally end up in the produce, and this produce ultimately goes to the human beings. Of course, there are very minute but significant role of post-harvest contamination that is not related to antibiotics, but it may be related to drug additives and some flavoring agents, some coloring agents, which are also important. Malachite green is one such agent, which are also important to note that some of them can be harmful, and the agencies world over are banning them also. So it is literally, I can say, literally a free for all for the poor hapless animal. So it receives these drugs from all the sources, all the possible sources that you can think of, and how much of that comes to your dining table is the key here. And the question is always, even to me, even today it occurs to me, even as I was preparing for this lecture, am I really threatening people? Are we threatening people about the presence of antibiotic residues? Or are we overreacting? Are we alarming people? So I'm just taking 3 studies. Of course, the hundreds of studies are there. One can easily Google and find out. I'm just taking 3 studies, one of which is our own study, and some 1 or 2 papers we have quote from publications. This CSC study, this publication is from Lebanon, which what I have seen. So they have tested about 80 chicken samples, and they found that 19 of them, among 23% of them, contained at least one antibiotic, monocontaminated, and 53% were contaminated. 53% contaminated to more than one antibiotic, polycontaminated. And for example, Cipro, Enro, I'm talking about chicken meat. Cipro, Enro, Norfloxacin were found in these samples in high numbers. Tetracycline was found in high numbers. Amoxicillin and penicillin. Surprisingly, because we rarely come across use of penicillin, but this is Lebanon, this is not Indian data. So amoxicillin, ampicillin, penicillin G. So this particular study says that maximum number of antibiotic residues are present. This is again 2019 paper, I believe. In India, I can say the issue of antibiotic residue become more, I can say, more into the public domain after the CSC study in 2014. So this fantastic picture which shows a chicken, I think you can check it in the Google. So they have tested 70 samples from the New Delhi, in and around New Delhi, Gurugram and those areas, and 22.9% had at least one antibiotic, and 17.1% had 2 antibiotics. And one sample had 3 antibiotics, both enrofloxacin, doxycycline, and oxytetracycline. So you can say that almost more than 50% of the samples had some antibiotic residue. Of course, fortunately, they were all less than mRNA. Of course, we as an ICR project, we have been doing this work for the past 8 or 9 years, I can say, because even prior to that, we had HPLC and started working on this. And this project, thankfully, touch wood, is going on even today. And of course, we have done all this all over South India. For this presentation, I am taking only one data. So almost entire Tamil Nadu was covered, about 1,168 samples, and we had a problem in sanitization. So we had sanitized only Enron OTC. For Tylosine, we had used an ELISA kit method. We tried, but we could not sanitize in chicken meat. And we had taken the meats from all the retail broiler shop, broiler farms, and broiler wholesale places in all the districts, we can say. We had covered all the districts. This was over a 4 or 5 year period. And based on the number of samples, I am particularly heartened to see that the number of samples were number of samples positive were very less. And the number of positive above MRL was hardly only 11. So this was only with oxytetracycline. With tilmicos, with tylosine, enrofloxacin, we could hardly see any this thing. But this is again understandable because oxytetracycline tends to have a longer stay in the body, persistence in the body, whereas enrofloxacin stays hardly for 3 days. And tylosine is also very quickly thrown away from the body, whereas tilmicocin, another drug, of course, we have studied tilmicocin also in another project, in another student work, but that stays there in the body for almost 3 weeks. Even the companies, I think they promote tilmicocin for 14-day withdrawal period. We'll come to that later. So this is our result. Of course, very heartening to see that very minimal residue, but this is one type of study. Similar studies were also taken up in Jabalpur and Kolkata, and also I think Pantnagar. So those centers are also studying. That is a 15 center study, so multi-centric study all over India. And of course, this project is continuing. This process is also continuing. Another question, many nutrition scientists are here, many technologists are here. So there is a general question, because there are one of my juniors also, he worked on this area, whether processing of the food, is it going to reduce the residue? So this is one paper I have taken from 2018 or 2019, I'm sorry. So am I audible?
Yes, sir.
Am I good to go? Yeah.
Yes, sir.
Because when you are talking all alone, suddenly you don't know whether you are being received or not. Thank you. So this is one interesting paper that you can see that ciprofloxacin and oxytetracycline, they tried various methods: boiling, microwave, roasting, and shear freezing for 2 durations, 6 months period and 1 year period. The results are interesting. So freezing seems to be having very good effect. After 6 months of freezing, 62% of ciprofloxacin is gone, whereas after 1 year of freezing, almost no ciprofloxacin could be detected. But compared with oxytetracycline, you will see that it's very little loss due to freezing. Boiling, of course, seems to reduce 77% of oxytetracycline and 22% of ciprofloxacin. Microwave treatment, 80% of oxytetracycline is gone, whereas only 35 is gone. So roasting also not very significantly, but can also reduce. So one thumb rule or one take home that you can take from this slide is that yes, processes do reduce residues, but it is not known whether it is significantly reducing. Means even after processing, the drug is likely to be still present in the food that we eat finally. And in the discussion on this paper, I have seen that especially the oil-based frying methods, they say that the drug can easily go on into the oil medium also. So that means that really you are not escaping from the problem. The process may reduce a bit, but does not overall remove the antibiotic residue. So what are the factors that contribute to residues? So first and foremost is the poor management and extra label use, which is very common, ELDU, and failure to observe withdrawal time. I can say that is the most important point here. Coming to poor management, I already in the first slide I have been telling that these species have very high productivity. So the birds, you can imagine, within 6 weeks they go up to 1.8 to 2. Anywhere between 1.8 to 2.2 kg. So they are in the highest phase of growth. So obviously physiological stress in the highest in these birds. So when there is a slight letdown, when there is a slight fault in the management hygiene practices, obviously infections will take an upper hand. Overcrowding is there, already stressed animal. and there is no other way for the veterinarian or for the farmer except to resort to the use of antibiotics. Often it may be done without the consultation of veterinarian. Of course, we all know that even if you consult a veterinarian, he is going to prescribe an antibiotic. And of course, if you go to areas like poultry belt areas, there are many these agrovet companies. So where they sell this agriculture produce, so they also sell a lot of these antibiotics. And we have also taken a survey in these areas, and there are a lot of sale points or outlets where the farmer can go easily, readily go and buy without even the prescription. Of course, that is not a this thing problem. That is not a wonder, because in India we get even human drugs without prescription. So this practice of self-administering drugs or administration of drugs with the farmer himself definitely is going to provide a big relief for the farmer, but it leaves a lot of question when we talk about drug residue. So please take home message: antibacterial drug is not a substitute for poor biosecurity. If you are going to have poor biosecurity, if you're not going to take care of hygiene practice, I remember when I joined as assistant professor in this university, I was posted in a poultry center. It was a research center, UTRC we call, and I had a very respectable senior, Dr. Padmanabhan. So whenever he used to go to the farms, we used to undertake the trips. So I remember if the litter was very unhygienic, so he will go and ask the farmer, "Ennappa ella kozhiyum socks potrukku," means he'll ask what all the chicken are wearing shoes and socks, which means so much watery and so much this thing is there. So if you are not going to take care of your litter, then obviously that is a big source, and you will be forced to resort to your antibacterial use. Extra label drug use quite common in India, of course world over, but India is very much there. Why extra label drug use? It's not an abuse, no, only in veterinary practice, also in human practice. So it refers to usage of drug not as has been approved by the CDSCO in India or US FDA. So for example, we use lot of drugs that are not really approved in chicken. For example, penicillins, amoxicillins, fluoroquinolones, which are one of the most popular drugs, has been banned in the US FDA for use in chicken long back. There is a very interesting story about it, and still it is one of the popular drugs being used. Use of the human drugs, I told about cephalosporins, I told about some of the penicillins, even they are used. They are not at all approved for veterinary deboned chicken. Please note, most of you, that some of the drugs, it is okay to use in pets, because pets ultimately they are not a food producing animal. So some of the human drugs, it is okay, though not exactly correct. It is okay if used in pets, but when it comes to use in food animal, you should really think twice or thrice. And also extra label drug use is constituted whenever you use a drug for a condition for which it is not approved. Like sometimes we use an anti-inflammatory drug thinking that it may take care of some immediate problems, but that anti-inflammatory drug may be staying in the body for a long time. So these are unapproved practices. And of course, another important point that we all resort to, that using a suddenly high dose. I have seen people doing this in mastitis case also. Certain times double the dose they give in order to, thinking that it will really take care of the problem. Definitely it will take care of the problem, no doubt, but it will leave a lot of residue. That is it. So this lecture is about the other aspect of therapy. So coming to extra label drug use, this FARAD, this agency. So I request to note down this agency's name, which will be useful to you. So FARAD regularly gives out some pamphlets and this thing. So they are classifying drugs as group 1 and group 2. So in group 1, we have drugs with no allowable extra label use. In group 2, drugs with allowed restricted extra label use. So of course, I'm not really worried about drugs like adamantane, neuraminidase inhibitors, because they're not much really useful, not indications in the poultry. But what I'm interested or what I'm worried about, the use of fluoroquinolones and cephalosporins, because these are the two important class of antibiotics today in the human practice. So any extra label use in veterinary practice is going to lead to a lot of resistance in the human pathogens. We'll discuss about resistance in one of the coming slides. resorting or restricting to withdrawal time. This makes very, very important. I think the class knows here the withdrawal time. For the purpose of this thing, for record's sake, I'll place it here, that mandatory time to be observed between the last dose of a drug and the slaughter or production of food from that animal. So please note that you suppose if the withdrawal time is 7 days, after the last dose, you have to necessarily wait for 7 days to slaughter or kill the animal and then use it. It is not like you kill the animal on the next day and then wait for the next 6 days you kept in fridge or freezer. That doesn't constitute withdrawal time. So you should give the animal to be alive for sufficient time to excrete all the antibiotics from its body. So that is the meaning of this clearance time or depletion time, or commonly known as withdrawal time. This ensures that the food will be removed of medicine and goes less than the MRL. MRL refers to maximum residual limit. And this is the problem here is that for drugs, this may go from a few days to several weeks. For example, a 15 days of withdrawal time can be a problematic for a broiler consumer, broiler farmer, because they come for market at the age of 6 weeks. Sometimes he has to resort to some antibiotic therapy during the 5th week. So if it is 2 weeks waiting period, he has to mandatorily wait for the 7th or 8th week of the bird, which is highly uneconomical, not economical for him, because after that the the FCR ratio, conversion ratio goes down, and the market animal doesn't fetch the market, and definitely is going to be at a loss. So this is a tricky issue, because from the science side you have to leave the animal unslaughtered or kept alive, but from the economy side, from the farmers commercial side, that is at a loss. So definitely this is a tricky issue. The best thing will be to make sure that you take care of your farm hygiene properly, so that there is no drug is given at least in the last 2 weeks of the bird. So it is the most common cause of violation when it comes to residue, when it comes to veterinary drug residue withdrawal time. This is a paper, 2017 paper. Of course, FSSA also come out with MRLs, but withdrawal time are taken from an international paper. So you can see ciprofloxacin 15 to 90 days. Really, it's going to be very difficult. Oxytetracycline 5 days is manageable, so just 1 week. But you can just think of a drug like ciprofloxacin, very, very popular, quite efficient even today, one of the best drugs. But is it really practical to wait for 15 to 90 days? So that puts a brake on the commercial aspect of the farmer. These are some of the studies that we have done over the last 10 years as a part of this project. So these popular antibiotics we have been testing, and MRL. Of course, this is not the MRL. This is not the withdrawal time. We cannot recommend withdrawal time. Withdrawal times are given by the agencies, but we can create studies that will pave them the way to understand. So tiamulin is an antimycoplasma drug, even today popularly used. Tilmicocin is also an antimycoplasma drug. So in between the two, you will find that tilmicocin stays for longer time, up to 18 days. Levofloxacin only 3 days. Doxycycline 28 days we have seen in this study, and oxytetracycline 14 days we have seen in the study. We have, of course, in these studies we have done all the kidney, liver and muscle. So I am quoting here the one that is there for the longest period. Sometimes the kidney stays longer, sometimes the liver also it stays longer. But what we have to understand is that the time required for the drug to go less than MRL, maximum residual limit, that is taken as the withdrawal time. So what will happen? Coming to the toxicology aspect. So what really happens if animal residues are there? So they hamper the health of human individual, also the human economy, because the huge loss in terms of health, in terms of hospitalization, what we are right now seeing in the COVID episode. So the world cannot afford more and more this thing. Today morning, a paper I have seen, our country needs 1 lakh more ICU beds. So you can imagine the cost it is going to have on the economy. Direct toxic effects can be seen. There are also some indirect effects. So alteration of gut microflora, beneficial microflora in the gut, they seem to play a lot of important roles. And nowadays, a lot of these probiotics and prebiotics are being discussed. So they may be altered when you use antibiotics. And antimicrobial resistance is one of the most important factors. We'll discuss about that. Some direct toxic effects like carcinogenity, teratogenicity, and reproductive effects. Of course, these are a lot very important when it comes to residues, because when we talk of residues, we are talking about low levels and ultra low levels. So these direct toxicity, carcinogenicity, teratogenicity, and reproductive effects occur only when there is a large direct exposure dose. There is a concept of superinfection, which is very, very important, because in a group of flora, normal flora, you can see that the blue one alone is a pathogen, others are normal. This thing. Let us say if this pathogenic organism becomes resistant, as it happens when a broad spectrum antibiotic is given. So when a broad spectrum antibiotic, it has the ability to kill all the bacteria, both gram positive and gram negative. So all the bacteria will be killed. Of course, unfortunately, this resistant one can thrive again. So after some time, what happens? You will see that only the resistant pathogen thrives. And if the resistant pathogen is going to be harmful, it is going to be pathogenic, then it's really leads to the biggest problem. So this is one of the common scenario that could happen in the presence of broad spectrum antibiotic. Your fluoroquinolones, your tetracyclines, so these are all broad spectrum antibiotics. Allergy to drugs. This is a direct toxic effect that you can see. It is said that 9% of human beings and 1.3% of human beings are allergic respectively to penicillins and cephalosporins. And the cause of true allergic response, what we call anaphylactic shock in the human being, can sometimes be fatal. It can lead to a severe shock. Shock is loss of circulatory failure or severe circulatory collapse, and can really be fatal. I know of one case in our veterinary faculty. One of my seniors, very, very successful senior, he passed away due to sulfonamide allergy, and he had developed severe anaphylactic and severe allergic symptoms all over the body, and he finally succumbed to that. This is not this thing, but this is very rarely to happen. But we must all know, put in the back of our mind that it is not impossible. I told you about anaphylactic shock, and whenever this happens, we have to treat and hospitalize the patient. Some of the other direct toxicity, nitrofurans, one of the most popular group of drugs, furaltodone, furazolidone. Of course, they are banned now. They are proven to be carcinogenic, not exactly directly carcinogenic, but they have shown a lot of clastrogenic, mutagenic property. Teratogenicity has been recorded with tetracyclines and aplastic anemia. This is very, very important. Why the whole world is afraid of chloramphenicol in both in aquaculture and veterinary product? Because of the severe aplastic anemia that it may cause. When I say dose independent, theoretically, hypothetically, even a single molecule can cause aplastic anemia, and this aplastic anemia can be fatal. So that is why there is a big hue and cry about chloramphenicol as this thing. And of course, needless to say, just like nitrofurans and nitrofurans, chloramphenicol is also banned for any food animal use. Of course, I already told that this kind of direct toxicity is less likely to occur when we talk of residues. This may occur directly when the animal is consuming, or directly accidentally when the human being consumed from the animal, from the box, or from the injection material or something. But as a residue through a food product like milk, meat, or egg, this is very, very less likely. But of course, the most important part here is the resistance. AMR, antimicrobial drug resistance. This is the most important reason for which we should really worry about antibiotics or antibiotic residues. So loss of effectiveness of a drug to a bacteria to which it was previously effective. Like yesterday, the drug was effective against bacteria A, but today the same bacteria A is not responding. The bacteria has become resistant. This is one of the biggest problems. Resistance, as we study in microbiology or in pharmacology, is a rule rather than exception, which means continuous use of any antibiotics definitely is going to bring on to resistance. But the human wisdom lies in identifying how much of a drug to be used and how much we can delay this inevitable resistance. So continuous exposure to antibiotics, as we have been discussing about tetracyclines, fluoroquinolones, it hastens the process of resistance. the whole world is seized of this importance of AMR. WHO has declared that AMR is one of the top 10 global public health threats facing humanity. Of course, these are in the public domain. We all know this. So it requires urgent multi-sectoral action. When we say multi-sectoral, food industry, medical industry, pharmaceutical industry, veterinary industry, livestock production, and all the groups, public health, all have to come together. Nowadays we talk about One Health. All of them have to. This is one best example of how One Health will play a role. All have to come together to minimize, to ensure that there is sustainable efficacy of these antibiotics, because you will note that last 20 or 30 years there has been exactly no new molecule. We are only playing the existing molecules and trying to bring new molecules within the available class. It is common knowledge in pharmacology that the drugs of the same class also share resistance, what we call cross resistance. So if if a bacteria is resistant to ciprofloxacin, it is equally resistant immediately to enrofloxacin also. So it becomes all the more bigger threat because we don't have no new drugs which act by totally different mechanism. And one of the most important drivers for resistance is the misuse, overuse, or shall we use the term abuse of antibacterials, equally in the veterinary and also in the medical practice. Please know that medical practices are also not very sacred. So they also abuse these antibiotics left, right, and center. No doubt about it. I'm sorry. So certain information has to be given. So this paper 2016 plus, it says about 10 million people will die due to AMR by 2050 if we are not intervening at the right time. So this is one paper. This is a Pakistan article I have seen. You can see how much of resistance is seen only from poultry isolates. For all the antibiotics, you take tetracycline, you take ampicillin, and you take naltrexonic acid. Please note that naltrexonic acid is a member similar to ciprofloxacin, erythromycin, and cephalothin. Please, cephalothin, erythromycin, ciprofloxacin, these are all human drugs. Means these are all available in the human being also. So much of resistance is already encountered. And in the same paper, they say that some isolates of bacteria, they harbor bacteria which are resistant to multiple class, tetracycline, ampicillin, erythromycin, sulfa, as well as cephalothin. So some 64% of poultry isolates have been showing resistance across different class of drugs. This is really alarming. This is not what else is. And of course, our own study we started doing this kind of study from 2005, and the first batch of students we had about 40 isolates of E. coli, and that time itself we could relate about 40 to 50% resistance to both the common fluoroquinolones. That time, thankfully, ceftriaxone even today is a popular drug in veterinary and human treatment, and that time ceftriaxone had not shown any resistance. Maybe the scenario would have changed by now. In our another study in 2016, one of our students, Dr. Kalai Selvi, he did her part of the thesis work. So we had checked for this extended spectrum beta lactamases. They are one of the most versatile kind of beta lactamases. They can code for resistance across bacteria. That is very important. So out of 31 isolates, 10 isolates had resistance for 3 different genes, meaning that they can be resistant to multiple bacteria by multiple mechanisms. That is very important. So they are most versatile enzymes coding for resistance. So what happens in a typical ESBL or extended spectrum beta lactamase kind of thing? So they can easily spread from one bacteria to another in a population. Just now I'm sitting here in my room, just around from me, from one bacteria to another easily crossed over. From parent cells to daughter cell, it very easily crosses over. From one species to another species, this is very important. Some species of bacteria could be innocuous, could be harmless, but even they may not cause disease, but they can cause resistant pathogen, resistant bacteria, resistant gene. This resistant gene can again spread on to some other pathogenic bacteria. So imagine what will happen. And another important point, what is being discussed all over the world right now is that these beta lactamases are stable in the environment. We call the hospital environment, we call nosocomial. You can put all environment. We can talk about pathogens. We can talk about testing laboratories where they test for bacteria and ABSD. We can talk about laboratories where they do research. We can talk about farms, livestock farms, milk yard, or cattle shed, or even poultry shed. So these are all environments where there is a preponderance of bacteria and high exposure to antibiotics, and therefore you can expect very high levels of resistant genes simply floating in that place and threatening to cause resistance at any point of time. How to prevent drug residues comes the next part of our topic. So good farming practice, the importance has already been mentioned in this class, and use of vaccines to prevent occurrence of infection. Vaccines are quite widely used. Of course, we don't have vaccines for very many bacterial diseases. Of course, there are attempts for disease against like E. coli or sometimes against mastitis. There are attempts, but I don't see any successful. There is attempt, of course, for coccidiasis in chicken. Coccivac is available, but often they coexist, viral and bacterial diseases. So whenever there is a viral disease, immediately it is taken up by the bacteria also to form a secondary infection. So if you are able to keep the viral disease in check, automatically you are going to control the bacterial disease also. Therefore, the need for using antibiotics becomes lesser. Extra label use, I have already discussed that should be avoided, and withdrawal time to be properly adopted. So that is also, these are some of the, looks very simple but really difficult to adopt in practice. Encouraging the use of alternative medicine. This is coming up in slightly bigger way of late. So Tanu is also promoting. We have one center, and my senior and respected senior Dr. Punyamurthy has been doing a lot of this work, even in the poultry sector. And of course, apart from alternative medicine, there are also other approaches. I'll show in the next slide. And the residue monitoring program. We are doing this program for the past 10 years. And we are trying to really exactly identify what is the status of residue. And please note that this cannot be a one-time project, one-off project. There has to be a continuous monitoring. And creating awareness about all the stakeholders, among all the stakeholders. So therefore, it becomes very vital. In fact, in one of the survey, I was happy to see that at least 50% of farmers, they knew the concept of withdrawal time. They knew the concept of residue. Though not, we don't know how much they really adopt, because they may not exactly know for each and every drug so much is the withdrawal time, because beyond the point it becomes too technical, and therefore it becomes very difficult for the farmer to follow. One thing they can do is, as a thumb rule, they can have at least 2 weeks time for any drug. So as I told you, for a broiler farmer, no drug shall be given beyond 4th week. So that makes the problem easier, and that kind of knowledge can be taken to them. So antibiotic alternatives, just now I was telling about phytogenics. So you also have organic acid and enzymes. These two are coming up in a big way in poultry industry now. Of course, I am not the best person to talk about that. Maybe they are going to talk about that in some other lecture. Of course, probiotics and prebiotics, these are actual bacteria, and these are nutrients for these beneficial bacteria, like some of the lactobacillus, etc. And antimicrobial peptide, even today a lot of research is going on, but we are trying to tap the natural resource of proteins which could act very well as antimicrobial. They may not be very effective, but probably their resource can be tapped, and maybe we'll arrive at an alternative sooner than later. The bacteriophage and hyperimmune therapy is not going to be practicable in a large in a large group like poultry, but bacteriophage and all, it's coming up, but I can say it's only at the research stage. But of late, of course, in the current scenario in the market, you have probiotics, prebiotics, and enzymes and organic acids. They are being marketed very nicely, and I think some expert in this group will know more about that. But other things are in the research scanner. Coming to MRL, maximum residual limit, this is fixed by the government of the day, Indian government or the European Union or the US EPA, Environmental Protection Agency, or commonly in the UN, in the what is called the Codex Alimentarius Commission. So the maximum concentration of residue of a veterinary product which may be accepted by the union. union year signed for the government to be legally permitted and recognized. So it is established keeping in mind the safety of the consumer. I am eating it, you are eating the meat, you are drinking the milk. So you must know how to, you must really have an awareness how much is tolerable and therefore how much I can take. So then if it is below MRL, then you can say that the food is safe to consume. And of course, most of these are commercial issues. Most of these issues are technical issues, or you can say techno-commercial issues. There is involvement of lot of trading. There is involvement of inland as well as international trading. So you need to have some quality benchmark or quality point. So MRL serves as a legal endpoint. If there is a dispute among two, you can say, stakeholders about the quality of the product, then MRL comes into play. So that becomes the identifiable legal endpoint to settle the matter. How do you fix MRL? That is also very interesting. So we have to conduct long-term toxicity tests in case of rat or mice or similar species. So we conduct a 90-day study, we conduct a 180-day study, we conduct a chronic study for 1 year. We also conduct carcinogenicity, reproductive study, any such long-term study. And we note the dose at which no adverse effect is recorded, which is called the no observed adverse effect limit or level. And we arrived the MRL. The MRL, of course, for food material, it is called ADI. For food ingredients or nutrients, it is called ADI, acceptable daily intake. In case of veterinary drugs or contaminants, we call it MRL, maximum residual limit. So NOAL divided by a safety factor, usually 100. So for example, if NOAL is 5 mg, and then ADs can be fixed at 0.05 milligram per kg ppm. So MRLs are fixed by government agencies. Codex Alimentarius Commission is international body. Most countries have fallen line into that. FSSAI is our own Indian agency, Food Safety and Security Authority of India, and FDA or EPA. Combinedly, they monitor the US market. Originally, if you look at the data of 5 to 10 years back, there are only 5 or 10 drugs whose MRLs are fixed. But nowadays, you see, I can say that they are updating their documentations every year. So many of the drugs in question, their MRLs have been fixed. And of course, if a drug is not fixed, then if there is a dispute, then the rule is that it should be considered as zero tolerance. No MRL should be, the drug should not be present at all in the drug. Once MRL is fixed, then it becomes mandatory for the agencies, for the farmers to strictly adopt to it. Especially if export is involved, this has a lot of legal implications. We have been told about a lot of earlier consignments in India, especially the shrimp and other some poultry products. Even some egg powder product was under some dispute some time back because of the quality issues such as MRLs. So FSSAI has recently in 2020, of course, they have come out with the draft. This is almost coming to law. And some of the important veterinary drugs they have kept. You can see that cattle, pig, sheep, and poultry they have already fixed. All these are in ppm, milligram per kg, 0.01, 0.015. Of course, that 0.05 is almost a thumb rule. You can see that most of them, especially pesticides, that be the level. So it's kind of a thumb rule. Of course, please note that these are all based on some actual long-term studies in smaller animals. Residue monitoring. So we need a lot of laboratories with with good instrumentation. In the present scenario, we need at least HPLC minimum. LCMS, MS is there. Of course, we have used some microbial assay and TLC assays in the past, and they're also being used. Am I there? Am I being received?
Yes,
Hello?
sir.
Yeah, thank you. Thank you. We need sensitive instrumentation because we are looking at very low levels. I can say ultra low levels of compounds, usually at ppb levels. If you don't know what is a ppb level, then this is what it is. 1 ppm is 1 liter of bucket or 1 liter of a solution dissolved and mixed in 1 swimming pool level of volume of water. Whereas 1 ppb is 1 ml of, just take 1 eardrop, 1 dropper, you take and mix it in swimming pool. Imagine that you are mixing the whole water with huge this thing, this thing, and then you are taking that one drop from a swimming pool and test whether that particular compound is present. So what I'm trying to say here is we are looking at very, very low levels. So obviously the instrumentation has to be very, very sensitive. So some of the instrumentation we can discuss here, just one slide per technique. So microbial inhibition assay, one of our students we tried, one IVRI scientist. For a short term we studied, we tried, but we could not get it. But this particular paper, 2019 paper, says very good the use of Geobacillus stereothermophilus. We also tried use of E. coli. We at our lab we tried Bacillus subtilis and E. coli. But this Geobacillus stereothermophilus, what they do is we can actually you can lyophilize them and use them, and you look for color changes. So it becomes very easy for reading. So this particular method says for 34 antibiotics and can detect up to a moral level. So it has been shown to be having good specificity, means it is able to distinguish between drugs. But only thing is it is not a very, very accurate tool. So it is good as a starting point, as a screening tool. ELISA kits, we have tried with oxytetracycline, tylosine, and then thiamulin. We have tried 3-4 different drugs. The simple principle is that drugs are very small molecules. They are not antigenic themselves. So we are more going to coat the drug with some protein. So it becomes a hapten, we call, and that protein is used as a target protein, and the antibodies are raised against that. So whenever there is an antibody antigen binding takes place, you have a substrate which is obviously colored. So based on the color development under a OD value, you can find out the concentration of this thing. So you have direct, indirect, sandwich ELISA, multiple ELISA methods are available. The goal is either use antigen with antibody, or sometimes one antigen, one antibody, and one anti-antibody. Finally, they are all tagged to some color chromogen, or tagged to some fluorescent body, tagged to some avidin biotin concept, something like that. So, or even some radioimmunoassay, something like that is bind. ELISA kits, we have used ready-made kits. We have been trying to make them. Of course, it is not impossible. Only thing is you need to raise the antibody. Quite sensitive, but the methodology itself shows some false positives could be there. So not really this thing. Of course, one big advantage is that in single day you can finish about 50 to 100 samples. That's a big advantage. So large scale screening, it is very good. And what is important, we have seen it is very sensitive also. It can go up to 1 ppb. Normally residues, the levels are 150 to 100 ppb. It can go up to lower than that 1 ppb. TLC, of course, is not a very popular method for this purpose, but it is manageable. For example, Danuva's mycotoxin we used commonly, and we found that we have been able to make it semi-quantitative, that we can even detect the quantum. So for those who may not know some basics of TLC, so we are going to make a spot like this. So we can spot the standard as well as the sample, and you allow there is at the bottom there is this is a glass plate, and this glass plate will be rested on a tank containing a solvent. The solvent will rise up due to capillary force, and when the solvent rises up, it takes this components. It takes the drug in the sample, the toxic in the sample along with that, and you identify the compound in both the spottings based on the RF value. This is the RF value, the distance traveled by the compound divided by the distance traveled by the whole solvent. So this RF value, if it is equal, then we can say it is going to be fantastic. Of course, this is a qualitative method, not exactly foolproof, and it is very, very less sensitive. It can go only up to ppm level. Of course, we have tried at ppb level. It works, but I can say agencies do not approve it. We have an improved version, HPTLC. It's also commonly well promoted, but of course it is a costly affair. It takes a minimum of 15 to 20 lakhs. HPTLC is an improved version with a pre-coated plates, very low sample volume, only 1 microliter, something like that. The development conditions, the solvent conditions are very, very precise, and separation is better than TLC, and it has its own scanning method. We do not have to spray any coloring agent, spray any acid or something. So this is advantageous, highly efficient compared to TLC. You can use multiple scanning method, detector method. The migration distance is smaller, and therefore analysis time is very, very rapid. And it is going to consume very less amount of mobile phase. When I say mobile phase, please note that we are using all organic solvents. These organic solvents are not good for the environment. So any method that reduces their use is a good method. Of course, the most important, most versatile method is HPLC, which we have been using now in our lab. We have both HPLC and GC. We have been standardizing some 8 to 10 antibiotics for HPLC, and recently we have standardized 2 pesticides, chlorpyrifos and deltamethrin for GC. So we are, when it comes to drug residue, MRLs, HPLC is more commonly used. The advantage is low sample volume, very precise flow, 1 ml flow rate, it can go on for hours together, very clear separation of unlights, so there's no doubt about the specific peaks. Very, very sensitive measurement, usually can go up to 0.05 pp microgram per ml, which is better than, or which is more sensitive than the normal levels of MRLs of any this thing. Very high reproducibility, so you don't have to worry that yesterday it was working, today it does not work. And versatile, when I say versatile, I'm talking thumb rule says about 80% of the Earth's chemicals can be tested or can be separated and tested by HPLC. HPLC, what it contains is this is a solvent reservoir. From solvent reservoir, we feed it onto the pump. This pump is a very, very, I can say the pump is the most important part because it delivers the flow mobile phase at a specific flow rate. And this is the injector. We directly inject. Once we inject the compound, only 20 microliter we inject. This mixes with the mobile phase coming from the pump and enters the column. The column is the heart of the HPLC machine where the actual separation takes place. Once the fluids come out of the column, they are detected with a detector. You can have a UV spectrophotometer, you can have a fluorimeter, you can have a refractive index detector. So many, nowadays we have a PDA detector, photodiode array detector. So multiple options are there in this. And finally, it all comes out as a peak in a computer. So what we see here is a peak. That peak will quantify, that peak will identify and also quantify the compound of interest. World over, in the last 2 decades, the in thing is the mass spectrometer. The mass spectrometer would have been, we will be talking about mass spectrometer only in the air maybe 1 decade back. But now, if you look around the institutes, almost any institute of birth has at least 1 MS. If I am correct, onwards at least has 2 or 3 right now. I am sure all the institutes have already built up their capacity. So it has become the in thing. So LCMS has become, I can say for some of the MRL studies, has become the basic. Globally widely accepted, currently it dominates most analytical in the last 10 years. Most of the mechanism, if you look at, if you Google or if you PubMed, you will find that the predominance of analytical techniques has moved over from HPLC to MS. So we call them hyphenated techniques. We have an hyphen, liquid chromatography, hyphen mass spectrometry, GC, gas chromatography, hyphen double MS. So all these are called hyphenated techniques. Means you need a preliminary separation technique like LC-GC followed by an identification quantification method using an MS. And most regulations, just now I told you, they require MS techniques. Of course, needless to say, it is a kind of a white elephant because it becomes very difficult to manage. So you should really have so many projects or so much of a current requirement in the lab so that you are able to maintain it successfully throughout the year. One last word about the monitoring program. So as I told you, the requirement of monitoring has to be a continuous process. There cannot be piecemeal work. So with that in mind, ICR has continued to work, allowed us to work in this project continuously for the past 7 years, and I hope it will follow through. And like that, there are 15 such centers. Similar studies have also been taken up by FSSAI because now FSSAI is also linking laboratories with accreditation. When it comes to accreditation, slowly even our project, now we are all forced to go for accreditation, at least for one or two compounds for which we have a steady method. So I hope that process will happen in the coming years. So accreditation becomes very, very important. NABL, National Accreditation Board for Laboratories. So this accreditation becomes the hallmark for you to be eligible to test any product. So FSSA recently is trying to encourage such regional laboratories to establish NABL accreditation so that they are able to send the sample anywhere. Training is very, very important. These are sensitive equipments. These are very requirements. Equipments that require good maintenance. Therefore, training and some level of basic education is required. Performance level is very important. So maximum residue limit is what the government fixes. Minimum residue performance limit is also another important tagline or catchword, I can say. So whenever you want to do, I must make sure, that is why NABL accreditation is important. I may make sure that my laboratory confidently can test at this low level, this sensitive level, 0.05, 0.03. So I must be able to give a guaranteed level of residue performance. Means in case of residue detection. And needless to say, most of the reagents and manufacturing, AMC itself runs for lakhs together. So these are some of the, I can say, small irritants in a continuous program. So what is suggested or what is thought over, because in our project also we have two teams which are working on microbial, one group is working on biosensor project. So what is discussed is that we can have cheaper, or you can say cost-effective methodologies for large-scale screening of milk or meat samples or this thing at farm level, what you say cow side or lab farm side test. And if any sample is suspicious, if any sample is having high values, then you can take it for HPLC or LCMS for confirmation. So that is the, I can say, a practical way of approaching the whole issue. Raising awareness is very, very important. We also did one particular camp, and this year due to COVID we could not do in 2020. 2021 next month we are likely to have a camp. So all these stakeholders, vets are the primary sources who have to be told first, and pharmaceutics. Even today, pharmaceutics, if you go, people dealing in livestock pharmaceutics, and they talk about administration of these drugs day 1, day 5, or they say they shall be advised on such and such date, without really knowing what is the impact of residues. That is one thing that we have to note. So awareness camps, pamphlets, and label instructions on withdrawal time. Nowadays, it has become mandatory for food animal usage. A label instruction should be there in the pharmaceutical formulation on the withdrawal time. And the strict implementation of prescription-based drug supply. This is easier said than done. Even today, even in human practice, anybody can go across to any medical shop, even to registered or chain medical shops, and then get this thing, get a product for human treatment. Leave alone, you can much less to said about animal practice. And avoiding human drugs in veterinary practice, this is going to be talked about in the coming days. Already a lot of hue and cry is raised that people are identifying antibiotics as 3 different categories. Category 1 only exclusively for human use, not at all to be used for any animal practice. Category 3 only for animal practice. Category 2 drugs which are used both in human veterinary practice but can be given only in terms of extreme emergency in the animals. So that is how they are trying to classify, and slowly I'm sure it will be implemented also. So as the last slide, take home message from this talk. Antibiotics can decide, antibiotic use in food animals, today we are talking about chicken, can really form undesirable residues which are harmful to human consumer. And more than the direct harmful effect, very, very important is the resistance that can occur due to this antibiotic use in the bacteria. Because please note that bacteria are common, whether it's Staphylococcus, whether it's Escherichia coli. I was telling about Campylobacter jejuni. One thing that is I forgot to tell you, Campylobacter jejuni is a commensal in the chicken gut. Commensal, when I say commensal, it is not a harmless bacteria, it is not a harmful bacteria for the chicken. But you and I, the poultry farmer, the veterinarian, the poultry worker, so they touch they handle this poultry dropping everything and highly possibility of picking up Campylobacter jejuni. But C. jejuni in the human being is a pathogenic bacteria. And for all that, enrofloxacin is a drug of choice. So if enrofloxacin or ciprofloxacin become resistant, C. jejuni becomes resistant to these fluoroquinolones, this is going to be a big problem treating them in the human being. And residue testing should be carried out at national level with dedicated laboratories and government norms on MRL withdrawal time to be followed. So some of the simple but effective slogans on this area. Thank you so much. Thank you.
Thank you, sir.
Thank you, sir, for your nice presentation on antibiotic residues in poultry meat. So, participants, if you have any doubt or any questions, you can ask Dr. S Ramesh, sir.
Sir, Ramesh, sir.
Yeah, Ruben.
Sir, one more important thing is you talked about the presence of genes, TEM, SHV, AXA, CTXM.
Yeah.
Now, whether those phenotypically, whether they were assessed for MIC values, sir? Because presence of gene does
Yes,
not
yes, 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 yes. Of course, I didn't show that result. We have also done it phenotypically. Also, the resistance was recorded. Actually, we have taken only resistant type. We have isolated 31 isolates.
Okay, sir.
Among 40, 31 were found to be resistant, and we have found that only from the resistant isolates we have taken this.
Okay, okay, sir.
And actually, the such type of study is continuing. Now, one student has done for milk samples. Now, one more, another student we have given for poultry chicken meat sample.
Okay, sir. Okay, sir.
So, primarily, first we test the MIC and the ABST, antibiotic sensitivity and the MIC level. Only then we go to the genetic level.
Okay, sir. Okay, sir. It is nicely presented, sir. Anybody who doesn't know about residues, they would have understood it if they have sat in this lecture.
Thank you so much. Thank you so much. I hope it was useful.
Yes, sir. Sure, sure.
Yeah.
Yes, sir.
And, I thank the organizers. If there are no questions, of course. Sir, organizers, shall we close?
Yes, sir, yes, sir. So, once again, I thank Dr. S Ramesh, sir, for his wonderful presentation on antibiotic residues in poultry meat. Thank you, sir.
Thank you, friends. All
you.
have a great day. Stay safe. Thank you.
Okay, sir.
Thank you, sir.
I am leaving, sir. Thank you.
Thank you. Thank you, sir. We will close for today, and we will join by tomorrow morning 10 o'clock for the session on food-induced toxicants. Thank you, sir.